Hello everybody and welcome back to a brand new video, and in this video I'll be solving problem F, that is permutation distance from Atcoder round 283, like I promised in my last video. So let's move on to the solution. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. As you guys know, Newton Schools does this coding contest every month, and this month the name of the contest is Code Rush X, and the prizes are better than ever before. So you can win prizes up to rupees 10 lakhs, and along with this you can win placement opportunities in top product companies. So like if you guys want to play this for fun or you guys want to play this for placements, that is totally up to you. The contest will be on 28th of January. It will start around 9 p.m. and the contest will be 3 hours long. So there will be ample amount of time for you guys to brainstorm and solve good quality problems. So if you guys want to benchmark yourself or just win some placements, this is a very good opportunity. I will leave a link to this contest in the comments and in the description, so you guys can go and sign up from there and show, or you can flex how good you are at problem solving. So now let's move on to the solution. So in the problem, we have been given a permutation of integers from 1 to n, where your n can be up to 10 to the power 5. So something like p1, p2, p3, so on up to pn, right? And for every index I in this permutation, we compute a value d, right? Your value d is defined as absolute difference of pi minus pj plus I minus j, right? The absolute difference of pi minus pj and the absolute difference of I minus j for some index I and j. So for every index I, you have to find the value of j, which will give you the minimum value, which will give us the minimum value. Let's call this di. For some index I, we compute d of I as pi minus pj is absolute difference plus I minus j is absolute difference for some index j. So for every index I, we have to find the index j, which will generate this minimum di value, and we have to print for every index I this di value, right? So that is the problem. If I have to write it as a statement, you can say for every index I, print the minimum di value, or basically you can say that find the index j, which will give us this minimum di value, right? That is the same thing. Now how can we solve this? So let's move on to the solution. So we can say that your di is basically minimum of pi minus pj plus I minus j over all indexes j, right? Where your j goes from 1 to n, but it is not equal to I, right? That is basically your definition of di. The only problem here is these absolute differences, right? If we, like, for the time being, let's ignore these absolute difference. So like if we ignore the absolute difference, we get your d of I is equal to minimum of over all j, right? You can say over all j. I ignore the absolute difference, so I get pi minus pj plus I minus j. I can like add these values together and I can add these values together. So I get something like d of I is equal to minimum over all j pi minus I minus pi plus I minus pj plus j, right? And like I know the value of like index I know value of I and I know value of pi, so I can move these out of the minimum value. So my d of I becomes p of I plus I, and as there is a negative sign here, this minimum will be converted to max. So I get p of I plus I minus maximum of pj plus j, right? That makes sense. You have to compute the minimum of this entire expression. So if you want to compute the maximum of this entire expression, and if there is a negative sign, so you have to compute the max of this value, right? So I hope that makes sense. That is one of the mathematical laws. So your di becomes p of I plus I minus maximum of pj plus j, right? And this value is very easy to compute. This value, maximum of pj plus j, this is very easy to compute. For every index, you can store p of j plus j, and you can just run you can just run a range query and find this value, right? So you can see that like if you remove the absolute difference, the problem becomes very easy. So the only problem here is the absolute difference signs, right? So that we have observed. So now we will like break this problem into cases. So like if you have a like absolute difference, there are only two possible cases. Either it will open as a negative or either it will open as a positive. And here we have two absolute differences. So in total, we will have 2 into 2, that is 4 possible cases. And as we saw, like when you remove the absolute difference, the problem becomes very easy to solve, right? So now let's draw out these 4 possible cases and try to solve the problem for each case. So we have your d of I is equal to minimum of pi minus pj plus I minus j, right? So the first case is when your I is greater than j and your pi is greater than pj, right? So in this case, your di will be minimum of pi minus pj plus I minus j. And if you club the items together, you get your d of I is equal to minimum of pi plus I minus pj plus j. And like if we shift the minimum here, because we know the value of these two elements, right? So we can shift these outside the minimum. We will get d of I is equal to minimum of, d of I is equal to pi plus I minus maximum of pj plus j. So I can write this in a beautiful manner. So right, so this becomes the first expression, right? This is your case 1, you can say, when your I is greater than j and your pi is greater than pj. So how can you see this? So if your I is greater than j, that means like in the permutation, your element pi is occurring after j. So you can say your element pj is on left of pi, right? Your element pj is on left of pi. And here it says that your element pi is greater than your element pi, or you can say your pj is smaller. You can say your pj is smaller than pi, right? That is the first case. Now let's move on to the second case. Let's say when your I is greater than j and your pi is less than pj, right? So in this case, your di will become minimum of I greater than j. So you will get pj minus pi plus I minus j, right? So this will be di is equal to minimum of pj minus j minus pi minus I. Again, if we shift this here, in this case, right, we know the value of pi minus I, so we will not shift the minimum over here, right? The minimum will stay with pj minus j. So your d of I will become just minimum of pj minus j minus pi minus I, right? Because in this case you are shifting the minimum over a negative sign, so it changed to max. But in this case your minimum will stay with pj minus j, so it will remain minimum. It will not change to maximum. So let me beautify this. So you get d of I is equal to minimum of pj minus j minus pi minus I, and I can say this is your case 2. In this case 2, your like element is lying on the left side of pi and it is greater than your element, right? So let me outline these words. So we get smaller and we get left. Here it is left and it is greater. You can generate the other two cases as well. So case 3, when your I is less than j and your pi is greater than pj. So you will get your d of I is equal to minimum of pi minus pj plus j minus I. So again, if you club the items, you get d of I is equal to minimum of pi minus I minus pj minus j. Again I will shift the minimum over here, so I will get your d of phi is equal to minimum of, or not minimum, we'll get your d of phi is equal to pi minus I minus maximum of pj minus j, right? So this is your third case, that is your element is lying on the right side and it is smaller. So the only case left is the fourth case. Let's talk about that also. So we have case 4, where your I is less than j and your pi is also less than j. So in this you get your d of phi is equal to minimum of pj minus pi plus j minus I. So you get your di is equal to minimum of pj plus j minus pi plus I. So your di is equal to minimum of pj plus j minus pi plus I, right? So this is your case 4, and here your element is lying on the right side and it is greater, right? So now we have 4 cases. So now let's try to write the permutation and see how we can solve for some index I, right? So if I write the permutation, I will get your p1, p2, p3, p4, so on up to some element pi. I want to find the answer for this element pi, and so on I will move on to pn. So we have 2 cases for the left side, right? Like if the element is lying on the left side, either it will follow case 1, right? Either it will follow case 1 or either it will follow case 2. And if the element is following case 1, I have to keep the track of maximum of pj plus j, and if element is like following the case 2, then I have to keep track of minimum of pj minus j. So for elements on the left side, elements that are on the left side, let's say some element j. If my p of j is greater than pi, that is if the element is greater, then I have to keep track of minimum of pj minus j, and otherwise if my element pj is less than pi, then I have to keep track of maximum of pj plus j. Let's ignore the right cases for now. Let's not talk about the cases for the right. Let's ignore these for now, because to solve the right side you can just reverse the array, right? Just reverse the array and like you can do the same logic again. If you guys want to understand the logic, we can just look at the left side, and once you understand the logic on the left side, you can easily extend that to the right side as well, right? So let's only look at the left side for now. So we have 2 cases where your pj is more than pi and your pj is less than pi. So for pj greater than pi, you have to keep track of minimum of pj minus j, and for the other case you have to compute maximum of pj plus j. So now how do we compute this, right? So now the point is, how do we compute this? So to compute this, we can keep 2 segment trees, right? We can keep 2 segment trees. Let's say this is my minimum segment tree. So this is my minimum segment tree, and in this I will update my pj minus j values. I will update my pj minus j values. Then I will keep one more segment tree. Let's call this the maximum segment tree, and here I will update my pj plus j value. So I will use my pi values as my keys, right? So in my segment tree, my pi value will act as my key. For example, first my pointer will be here, right? So I will start iterating from the left. So I will first see my p1 value, and I will find my p1 value here, right? So let's say my p1 is lying somewhere here. So here I will update my pi minus I, my p1 minus 1. Similarly, in my other segment tree, I will update my value p1 plus 1. In my minimum segment tree, all the values will be infinity, right? Initially, all of them will be infinity. Similarly, in my maximum segment tree, all of my values will be minus infinity. Then I will go to my p2 value, right? I will go to p2, So let's say my P2 is lying somewhere here. Let's say my P2 is here. Then first of all, I have to like find the answer for P2, right? I have to find the answer for P2. So P2 is also here. So my answer for P2 is either it will follow case 1 or either it will follow case 2, right? So if it is case 1, which was Pi plus I minus Pi plus I minus maximum of Pj plus J, right? So in this case, I will query my segment tree. I will query my segment tree on which side? In this case, like if we see here, my Pj is smaller than Pi, right? My Pj is smaller than Pi. So like for P2, I will have to query on the left side, right? Because all these Pi values are less than P2. So I will query on this side, right? I will run a query here, and this will give me the maximum Pj plus J value for Pj values that are less than Pi, right? So I will query on this side, and then I will find the answer for P2. In case 2, here is case 2. So that is minimum of Pj minus J. For case 2, it's P2 is equal to minimum of Pj minus J minus Pi minus Psi, right? And in this case, your Pj was greater than Pi, I think, right? Your Pj was more than Pi. Yeah. So in this case, now we know like my P2 is here. So I have to like look for the Pj values that are greater than this, right? So in this case, we will query on the right side. We will query on the right side. And this will give me the value of minimum of Pj minus J for values that are greater than Pi. And then I will update my answer for P2, right? So for both of these cases, I will update my answer for P2 as minimum of answer of P2, the answer that I found using case 1, right? So the answer that I got from case 1 and the answer that I got from case 2. Similarly, I will find the answer for case 3 and case 4 as well when I reverse the array, right? So when you reverse the array, find the answer for, after reversing, find the answer for case 3 and case 4, and your answer will be the minimum among all these answers, right? So I hope that is making sense. So after you find the answer for P2, now you also have to update this, right? So like remove the infinity from here and just update P2 minus 2 here. Also remove the minus infinity from here and update P2 plus 2 here. Then just move on to P3, right? Move on to P3 and similarly find the answer for P3 as well. Let's say your P3 is lying here. Then you will again query on the right side here. Let's say your P3 is here. Then you will query on the left side here. So like similarly, you will keep on finding answers, right? Then you can just reverse the array and do the same thing for the reverse case. So if I have to write the logic for this, we will have two segment trees, right? One is the maximum segment tree and other is the minimum segment tree. So for every I going from 1 to n, right? Like consider the cases, case 1 and case 2, right? Find the answer for Pi, then update maximum and minimum segment tree with this Pi value. Then you can reverse the array and find the answer for case 3 and case 4 similarly, right? Find the answer for case 3 and case 4. So that will be the entire solution. And if you guys want to see the code for this, here is the code. Let me maximize this, right? So I have two segment trees. One is the minimum segment tree. The default value in this is infinity, right? Like I told you, in the minimum segment tree, your default value should be infinity. Similarly, I have the second segment tree. Here, the maximum segment tree. Here, the maximum value. Here, the default value is minus infinity, right? M minus F. So I will just first take my array as the input. Then I will do two iterations. I am doing two iterations because the first iteration is for the normal array and then it is for the reversed array, right? So instead of making two separate blocks of code, I just like wrote a simple for loop, and for the first iteration my array will be state, and for the second iteration my array will be reversed. So I will go over for long I equal to 0, I is less than n. So I will iterate over all the elements of the array. For iterator is equal to 0, that means this is for normal array, right? If the array is normal, or you can say if you want to find the answer for case 1 and case 2, you will do it here, right? To find the answer for case 1 and case 2, do it here. And if the array is reversed, you have to find the answer for case 3 and case 4 here, right? So my answer of vi is equal to minimum of answer of vi. This is vi plus I plus 1 minus maximum dot query 1 comma vi, right? So like if I come here, this is the first case, right? That is pi plus I, and then I will query on the left side in the maximum segment tree, right? So this is the following thing: p of I plus I minus query from the maximum segment tree on the left side. Similarly, this is case 2, query on the minimum segment tree on the right side, right? So this case, query on the minimum segment tree on the right side, and minus pi minus I. So it is, where's my mouse? Yeah, so it is pi minus I. So after you're done with this, update your minimum segment tree and maximum segment tree. At the position vi, you will put vi minus I plus 1, and in the maximum segment tree at position vi, you will put vi plus I plus 1. And in the second case, we'll compute when your array is reversed. That is, we will compute case 3 and case 4. It is also very similar, but the only difference here is that like you have to keep care of the cases, because like when you reverse your array, so let me show you, right? So we have p1, p2, p3, so on up to pn, right? Here index is 1, index is 2, index is 3, and here index is n, right? So we are computing p1 minus 1, p2 minus 2, and so on. But when you reverse the array, you will get pn, pn minus 1, pn minus 2, and so on up to p1. But now index here will be 1, index here will be 2, here will be 3, and here it will be n, right? So like we don't want to compute pn minus 1, we want to compute pn minus n. So you have to convert this index as well, right? So if you have some index I, you have to convert it using n minus I as well, right? So that is why we are using n minus I here instead of normal I or I plus 1, right? So like keep that in mind. So when you have done both the cases, you can just iterate over your answer and print the answers, right? So that will be the entire solution. And if you guys have some doubts, feel free to join my Discord server. I will leave a link to it in the comments, and I will see you guys in the next one. Bye bye.